Have you ever tried sitting on a bicycle while standing completely still? The second a rider lifts their feet, gravity wins, and this heavy metal machine tips straight over onto the pavement. So how does this exact same clunky frame suddenly become perfectly balanced the moment you start pedaling? A moving bicycle is so incredibly good at staying up that if you give it a push, it can glide perfectly upright completely on its own without a human steering it at all. Now, unless there's a crew of tiny invisible ninjas running alongside holding the frame steady, something else must be happening. To figure out how we cheat gravity, we need to shrink down and look at the hidden forces of physics acting on those moving parts. What we'll find is the ultimate tag team, a continuous partnership between the rolling machine and the rider sitting on top of it. The first member of our tag team is the wheels. Once they start spinning fast, they create a special energy that actively fights against gravity. Look closely at this brass instrument. When a bike's wheels spin, they act just like this. They become what scientists call gyroscopes. A gyroscope is simply a spinning object that wants to keep spinning in the exact same direction. Once it gets going, it strongly resists leaning to the left or the right. You've probably seen this action in a spinning top toy. While it spins, it can rest on a tiny metal point without tipping over. This happens because of momentum, the invisible pushing force that keeps moving objects going. The bicycle's job is to use that spinning wheel momentum to build a kind of invisible shield, keeping the bike rolling straight up and down instead of flopping sideways. But those spinning wheels can't balance the whole ride on their own. They need their tag team partner, you. As you ride, your brain acts as a hypersensitive sensor. It constantly feels for the tiniest sideways tilt of the bicycle. When your brain feels the bike leaning left, it instantly tells your hands to steer into the fall. It slightly turns the handlebars to the left too. That quick steering motion scoops the wheels back underneath your body's center of weight, catching the fall before it happens. Turns out there are invisible ninjas holding the bike up. It's you. Your brain and body are making hundreds of microscopic, lightning-fast corrections every minute, completely automatically. Balancing a bike isn't about sitting perfectly still. It's a continuous, hidden dance of tiny wobbles and instant brain corrections. If you pedal slowly, the wheels don't spin fast enough to build up that gyroscopic momentum, making the bike super wobbly and much harder to control. This boy is using training wheels. Because beginners ride slowly, they give the brain a safe zone to practice tiny steering corrections without tipping over. Plus, without those wheels, the slow bike is just too tired to stand up. But scientists have proven that once you pedal fast enough, the shape of the bicycle's frame and the momentum of the wheels are strong enough to keep it rolling along smoothly without a rider. Speed gives the machine the power to fight gravity, freeing up your brain to just enjoy the wind in your face. Let's see what you remember. Question 1. What scientific object do fast-spinning wheels act like? Gyroscopes. Question 2. What part of your body acts like a ninja to make tiny balance corrections? Your brain. Question 3. Is it easier to balance a bike when going fast or going slow? Fast. You aced it. Smash that subscribe button to join the lab crew for more science mysteries. Here's the final recap. 1. Spinning wheels equal gyroscopes. 2. Your brain makes microcorrections. 3. Momentum makes balancing easy. Next time you go for a ride, notice how much steadier the bike feels after those first few pedals. That's your momentum taking over. We know how a bicycle stays up, but how does your voice travel when you talk into a telephone? How do these solid wires carry words across a city? Tap right here to find out.